Hello, MK. We are looking
not gonna be
at
here for
chapter
drama.
12. So I've asked everyone to think of a noisemaker that they can bring in when we finish the information on chapter 12. Like I can bring in pots and pans to bang or something to celebrate when we finish the last idea in this book.
She could bring in her little brother. He's very loud.
All right, that
Bring
works.
Will.
All right,
And bring your little
let's
brother.
realize we're going back into quantitative land. Remember, we've been in categorical land with chi-square. We're
I'm
back.
to say quantum land.
Yeah, quantitative land. So we're going to be looking at numbers again. So are you glad, sad, or mad?
I just forget.
I'm not sure yet.
I just forget what those things
So,
mean.
what are some of the statistics that we've learned so far?
Blurry. Oh no, we're
Mean,
gonna do
standard
this list again.
deviations and proportions.
All right, but
The main
we
things.
remember the statistic comes from a sample, so we don't really
So
say
X bar,
mean, X bar,
SX.
You.
S of X.
Mew.
Mu is from the population, so that's
hat.
not a statistic, that's a parameter. So what else?
P hat.
P hat. All right. So those are the big dudes, right? So we're gonna add two more to this, but we're only gonna work with one of them. Actually, I'll add three more, but we'll work
Linear
with one.
regression.
Do we have
All right.
note-taking sheets?
Yeah, that would help, wouldn't it?
that-
All right, here we go.
I get linear regression.
This is for the whole, this packet is for the whole chapter, but we're just looking at the first 3 days. You know how we've been
This
going
is not
kind
quite good.
of, you can show one to MK.
Bang it up.
MK, I would have given this to you yesterday if I'd known you were going,
MK.
but you tricked me and said you were coming in
There you
to
go.
finish your test in 5 minutes.
Should I show her the
All right,
second
I
page?
forgive you
Wow,
totally.
it's a packet.
All right.
It's actually a packet. There's 3 pages.
Well, I'm saying it's the whole chapter, but we're looking at the first 3 days' work.
fine.
I don't know if we'll get through it,
It's fine.
but we'll take a stab at it. All right, so in the area below that chart of what's to come, we're going to take a few notes. So fairly small, doesn't have to be minuscule, but you're going to have a little bit of notes there. So I don't think you'll have any trouble fitting them on. So again, we're back to quantitative land. Perhaps you've seen that we're looking at more topics about linear regression. So let's review what we're talking about. More linear regression. Kind of a strange note to end on because it's unlike any of the other things we've looked at. But nothing surprises us now. So let's go ahead and look at what we're talking about when we say the word linear regression. If you recall, remember the backpacks? What was it? Weight of person. That was in pounds. And then weight of backpacks. Remember that? How many were there? Do you remember?
15.
8. There wasn't very many, and they went something like, so just draw 8 in this kind of ascending pattern, and we would draw a line. What do we call that line?
Least squared regression line.
All right, least
I don't know where that came
squared.
from.
Where did that come from?
I don't know.
Oh, it's
I was just like in my deep memory, and I don't know any math. Don't ask me to do any math.
All right, least squares regression line. Very good. And sometimes we called it the line of best fit. So this is a
The
more
goodness of
mathematical
fit
term.
line.
Right. So remember that line was placed so that it is not necessarily through any of the points, but is as close to as many as possible. And usually there's just as many above as below. So mine did a fair job of that. The calculator is able to give us that line more precisely than we are able to give it to ourselves. All right, so what are these thingies that I'm adding to this? See if that pops in from your past.
R squared.
No, that's when you put the squares.
They're going to turn into
They're
R
the
squares.
something with
They
an
did.
R. Residual.
Residuals.
Yeah,
Oh my
what
gosh. All right.
There is hope.
All right, so those lines are in orange are called the residuals, and they're going to come out to play a little bit. R squared is not, so.
Yeah, R squared. Just all the R words.
All right, so suppose we were trying to come up with a regression line, and we took a sampling of the backpackers. So say that there are hundreds of backpackers, and we picked 8. So what if we went back another time and took another sample of backpackers? So this time, they're still going to be ascending order, but maybe not as the same slope. So I'm going to put in the regression line. Am I going to get the exact same regression line each time?
Nope.
No, I'm not. So now I am sampling to get regression lines. I'm not sampling to get some of the other things we've seen, like proportions or means. We're looking at regression lines. That's what we're sampling for this time. So every sample is going to give us a somewhat different regression line. So therefore, let's call the sample regression line y hat. Here comes our hats again.
No.
Y hat tells me that it is from a sample. That's all it tells you. So y hat equals a plus bx. Do you remember which one is the slope?
B.
It is. So
Because it's whatever goes with X.
all right, so that was the slope, and a is the y-intercept. All right, so that again is from the sample. What would we call the regression line that is true for the whole population? So moving away from sample, the actual true one, which I usually don't know, and that's why I took a sample in the first place. But the true name is going to be y equals alpha plus beta x.
Times Roman numeral true and Arabic letter.
So this is the true y-intercept for the whole population. And this beta is the true slope for the whole population. So we're going to be estimating to the best of our abilities, and with all our statistical methods, we're going to find estimates that are close to alpha and beta, and we're going to call them A and B. So those are our new statistics. So I'm going to go up to my list here and add A and B. Those are statistics. They come from a sample, so understand that. All right, do you recall, before we go on, what the meaning was? Say that the slope of this line is 1/2, and we had weight of persons here, weight of backpack here. Backpack, or backpack, weight of person. So the slope, say the slope was 1/2. Do you remember the meaning we used to give for that? In fact, we didn't even put them in fractions. We always had them in decimals.
So it would be for every one person, no wait, for every one backpack, because it's rise over run,
Right,
there will
so
be, the weight of the
backpack.
person will increase by 0.5.
Not quite, because the rise has to do with the weight of the backpack.
So for every half of a backpack,
Right, we always
for every person, the backpack weight will increase by 0.5.
right, so every 1 pound.
Right.
So every 1 pound that for every 1 pound increase in weight of a person, the backpack increase is 0.5.
Just
So remember
quite
how we
throwback.
actually had to interpret? That's one of the first things I probably taught you to say. Say it like I say it. You know, how many times have we done that? 1,000 since
I hate
then.
the word interpret
I
now.
know.
I hate it.
I
It's like
know.
one of my banned words. I'm not allowed to say it.
So that's how we interpret slope. Do you recall how we interpret the y-intercept? So for this one, when we say interpret, I'll write that out. For every, and we always had a 1 here because we kept this as a decimal. Every increase of 1 And that's going to be in every problem. Then you'll mention whatever is on this axis. Interpret. For every increase of 1 pound or weight of person,
So isn't it like
backpack weight, I keep writing backpack weight increases by 1/2 pound. All right, so that's sort of a rise over run interpretation. And we always had a 1 there, if you recall. So 0.5 pounds in backpack corresponded with 1 pound weight in person. So what about interpret the y-intercept?
when there are no people, the backpack weight will be.
All right, and
0.
sometimes you recall there was no meaning for the y-intercept. It just didn't make sense.
Right.
And even
So
though
it's
it was
like-
mathematically sound, we had calculated the y-intercept correctly, sometimes it made no sense.
It's like, did it make sense when it would be like a negative number? Because it's like, when there is, if the y-intercept was like -2, then it would be like, when there is no people, the backpack weight is -2. Like, that
Yeah,
doesn't make sense.
exactly.
When there's no people,
So,
there's no backpack weight.
Maybe meaningless. Sometimes it has some good meaning, so we'll practice some of those. On backpacks, we would say, we could interpret it like this: 0 weight, which is pretty meaningless. How many people do you know that weigh 0? You don't have a person if you don't have any weight. 0 weight equals 0 backpack weight.
I'm sorry. Trying to adjust this.
So that's one that's pretty meaningless too. But, all right, so another thing I want to say foundationally before we go on is, slipping my mind. All right, come on, Olin. Oh, I know. So we actually gave names to this variable and this variable. Do you recall the names? What do we call the name on the x-axis, the variable on the x-axis?
It wasn't one response.
Yeah.
And
Yeah.
I don't remember the.
She's been studying.
I haven't. I just for some reason remember. I forget what the first
Well,
one
that's
is.
response. Do you remember the other one? Response variable and? MK, we need you.
What does it start with?
X.
Expected.
It doesn't start with an X,
Oh.
X sound. The response variable.
Explanatory.
Explanatory. There you
Oh.
go.
You got it too.
Remember, we remembered that explanatory was on the x-axis and y was response variable. All right, so most of this is from the past so far, except our new friends, alpha and beta. So, all right. In order to do inference, we are going to not use bits or rin
Do we
or
have to learn a
ril.
new one?
We have a new one, but it is the last one. And because this is a line, our new
Is it like
our
Lil?
new check is liner. All right.
Okay.
Liner. So you can give yourself a liner. All right. Check for inference. Before we can make statements about inferring what A and B, alpha and beta might be, we have to check. So here's our checklist before we can do our inference. Our inference will take the forms that we've always seen. They'll be in confidence intervals and test statistics. So once we get through this, it'll be old friends that we are familiar with. But liner is a big pain, so I'll just warn you right now. All right, the problem is you have to use your calculator to look at the data on various charts. So I have to remind you how to do a residual chart on your calculator, how to do a scatter plot, etc. How to
What
do
exactly is new
histograms.
here?
Huh?
What exactly is new here?
Only this, alpha and beta so far.
And that represents like a true.
That's the true y-intercept.
Population.
I mean, this one is from the true population, this is from the sample. So nothing new, it's so far review, and liner is new. Any guesses what L stands for?
Linear.
Linear. So the data has to be a somewhat approximately linear. So even though, before I drew in this line, did you see how the dots were proceeding upward? They can also proceed downward. There has to be an approximate or somewhat linear pattern. So you will check a scatter plot for that. You put the data in your calculator and look at a scatter plot, and you can decide whether, if it's totally random all over your screen, it does not pass linear.
Wait, you still
How many
do it.
minutes have we gone?
Probably 10. Do you want to shut down?
Yeah, just to
Bye.
make sure. And then, what is it? It's like 5 of, so about 10 after.
All right.
We'll do the next one.